Hey guys, welcome back. Hopefully you guys had an amazing Christmas vacation. Spent it with family, had fun. So probably by now you guys already know all the math teachers are out for today. We were out at a conference. So instead of starting something new from semester 2, what I do want to do is go back to semester 1 essential standards. And again, there's 5 total essential standards. Semester 1 covers 3 of them. All right. And again, why are we going back to semester 1? Well, semester 1 is going to carry over to semester 2. Your final for semester 2 is going to have these essential standards. And also, when you guys get to geometry, geometry teachers are going to require that you guys have mastered these. These are your need-to-know standards. All right, so you guys know how this works. Make sure you guys pause the video here. You copy down that title for me, Semester 1 Essential Standards. Remember, this is still in Cornell note style. All right, so let's get into it. So what was essential standard number 1? Well, that was, hey, let's solve a multi-step equation. We're solving for some variables x, y, z, whatever. In this case, we are solving for p. Okay, well, when you take a look at this example, make sure you guys copy it down. Let's see, what can I do? Well, I see that I have parentheses here, and I have this -6. So what I want to do is I need to, well, actually, before I get into it, some people like to draw this little line just to keep them organized. Let's do it. But here we have the -6, and I do want to distribute, not just to the p, but also to the +3. So what's -6 times p? Well, that's just going to be -6p. And then what's -6 plus 3? Times +3. It's going to be -18. All right. Now let me bring everything else back down. And again, I want to do one step at a time so I don't overwhelm myself. Break down my -5p. All right, so what can I do next? I have -5p minus 22 is equal to -6p minus 18. Well, I know that I have variables on both sides. Now, what I want to do is I want to get them over on one side. It doesn't matter what side. If I want to get rid of this -5p, I say plus 5p plus 5p. If I want to get rid of the -6p, I say plus 6p. Whatever I do to one side, I do to the other. So let's get rid of that -6p. Let's put plus 6p. Now plus 6p. Now 6p minus the 5p just leaves us with p. Drop down my minus 22. Drop down my equal sign. Well, of course, these guys canceled out. That's the reason we did it. Minus 18. All right. Now I'm almost there. All I have is a one-step equation. How the heck do I get rid of that number next to that p? Well, what's the opposite of minus 22? Inverse operation says I have to do plus 22. Plus 22. Okay, so I get p is equal to, well, 22 minus 18, that is going to be 4. So p is equal to 4. All right, guys, so this was essential standard number 1. How can you solve a multi-step equation? It's when you had distributive property, when we had combining like terms, addition property of equality, subtraction property of equality, division property of equality, all that good stuff. All right. So what I want you guys to do is, here's your example that I want you guys to try out. Now, here's the thing. I have standard met, and I have beyond standard expectations. And now, from this point forward, you don't have to do both, right? I just want to, I put standard met because this is where you should be. You should be by the end of this year. You should be able to do this type of problem. That's a guarantee. Now, some people say, oh, that's too easy. I need a challenge, right? So this is what I've put over here on the right-hand side. So what I want you guys to do, again, if you feel comfortable, standard met, you think you do that's too easy, go ahead, challenge yourself. If you're like, that looks a little tricky, then it's okay. See if you guys can try the standard met. All right, so it's up to you. Pause the video right here, and then I'll talk about the solution in a second. Alright, so here we have it. Here are your solutions. So again, depending on which one you pick to do. So let's go through the first one real quick. Standard met. Now, of course, you start off by distributing. 6 times 6 is 36. 6 times 5 gives you 30. Now, can I have variables on both sides? Well, how do I get them on the same side? Again, it's all inverse operations. What I did is I kicked over this minus 3k by saying plus 3k. And of course, these canceled out. Now, 36k plus 3k gave me 39. Now, again, I want to get that k by itself. How did I get rid of the positive 30? Well, I said minus 30 to both sides, so that guy canceled out. Now 30 minus 30, hey, that's kind of, well, it's kind of strange, right? We kind of rarely get this, but 30 minus 30 is 0. Now 0 is still a number. You can still work with it. So you have 0 is equal to 39k. Now don't forget, how do I get rid of multiplying by 39? Well, I have to divide 39 divided by 39 here. Of course, it cancels out to give me just 1k. Now 0 divided by 39, of course, is just going to be 0. All right, let's move on to the beyond standard expectation. Same thing, starts off with distribution, okay? Negative 3x, and then negative 3 times 5 is negative 15. Now what I did here was I combined it like terms. Negative 15 plus 2 gave me negative 13. Now, how do I get my variables on the same side? So notice again, I have this guy here, this guy here. I want to get them on the same side. So what I did here was I said, hey, let me kick over the minus 6x by saying plus 6x. Of course, these canceled out. Negative 3x plus 6x is 3x. Now, this becomes a two-step equation. Well, let's add 13 to both sides. It cancels out again. I get negative 25 plus 13 is negative 12. Careful with your negatives. Lastly, here I have to divide both sides by 3. Now, again, 3 divided by 3 is just 1. Or simply 1x. You can write the 1 if you want. And then negative 12 divided by 3 is negative 4. All right, guys, so that is standard 1. All right, that is a must know. All right, let's move on to essential standard number 2. Can I graph a linear equation? Now, if you remember, hey, this is in that kind of weird, funky form, which we call standard form. You got your ax plus your by is equal to c. Now, again, the way I like to graph this is change it to y equals mx plus b. Hopefully we didn't forget how to do that. Now again, the whole point is to get that y by itself. So you got to kick over the x. So how do I kick over a positive 7x? Well, let me say minus 7x. Minus 7x. Now these guys will cancel out, of course. Drop down. It's not just a 5. It's a negative 5y. Is equal to, now again, I cannot subtract these. I get this common mistake a lot. This one has a variable. This one doesn't. They're not like terms. So I just write them right next to each other. Negative 7x. Now that's a positive 10, so I say plus 10. Notice I'm getting that mx plus b, almost there. I have a number in front of the y here. It's a negative 5. How the heck am I going to get rid of that negative 5? If you remember, well, I have to divide. Since I'm multiplying, I divide everything by a negative 5. Divide everything by a negative 5. I end up with y. Of course, these guys cancel out. I'll give you 1. 7 divided by 5. That doesn't divide nicely. Leave it as a fraction. Of course, negative divided by negative is a positive, so let me just make it a positive 7 over 5x. I can always clean it up. Now, a positive divided by a negative is a negative. 10 divided by 5 is 2. Awesome. Now, here's the thing, guys. I have it graphed. The whole point of this is, can you graph it? Of course, you might have to manipulate it here and there. So let's go. Ooh, draw a better, straighter line than that. All right, here we go. Here's my attempt on this computer. Now, don't forget, you always want to start on the y-intercept. You always want to start with that y-intercept. Oops, let me go back real quick. Y-intercept, which is at negative 2. So on your y-axis, you go down negative 1, negative 2. There's our very first point. Now, don't forget, this right here, your m is your slope. That is your rise over your run. Now, of course, this is a positive, so I'm actually going to go up. If it was a negative, you'd go down. Now, this is telling you to go up 7, so count from here up. 1, 2, 3, 4, 5, 6, 7. And I'm going to go over 5. So let's go over 1, 2, 3, 4, 5. All right, so somewhere right there, draw as straight of a line. Ooh, that's terrible, but you guys get the idea. All right, so there we have it. I've graphed a linear equation. That is essential standard number 2. That is a need-to-know standard. All right, guys. Same deal here. I'll leave this for you guys. Again, standard met. If you're like iffy, if you're confident, go for beyond standard expectation. Now again, you only have to do one. All right, pause the video here. Go for it. All right, guys. Here we have it. Here are the solutions. So again, for standard met, you got to move over that 6x first by minus 6x. Now divide everything by that negative 5 that you bring down. Careful here, right? Negative divided by negative is a positive. Negative divided by negative is also a positive. And of course, 5 divided by 5 is 1. That's going to remain as a fraction. Now, where did I start? I started at positive 1. All right, and then that 6 over 5 tells me, hey, I have to climb up 1, 2, 3, 4, 5, 6, and over 1, 2, 3, 4, 5. I'm slightly off here, but you guys can see 5 should be right there. All right, now for the beyond standard expectation. So again, you start off, same deal. Notice minus 2x, right? But then when you go to divide by that negative 3, well, negative 2 divided by negative 3, that should be positive 2/3. Now here, that's the reason why it's beyond, is just you get a decimal, right? It's kind of funky. 7 divided by negative 3 is going to give you negative 2.33333, blah. So this is where I'm going to start off. I still have to graph at negative 2.3, which is negative 1, negative 2, and then a smidge right there. Okay. my slope says rise 2, run 3. So again, I still have to count up 1, 2. Okay, and then I go over how many? 1, 2, 3. So again, you got to be careful. You just kind of have to estimate this one because you are dealing with decimals. All right, guys, let's go to the last and final essential standard here. All right, so our last essential standard here is solve a system of equations. Remember, that's when we're taking a look at two equations at the exact same time. Now, what I want to do here, okay, I have three different options. Remember, I can solve this by graphing. Okay, I can solve this by substitution. And I can solve this by elimination. Now, of course, graphing wasn't the best because, of course, I don't have graph paper. It can get kind of messy, so we try to avoid that one. Now, my thing is, whenever I see these guys, and I'm like, hey, both of these are in standard form. You got your ax plus by equals c. I always like to fall back on elimination. That tends to be kind of the easiest approach here. Now, I want to eliminate either the y's or the x's. And here, to me, the x's are much, much easier. Because here I see that this is a negative 8x. Well, if I want to eliminate it, the top one has to be a positive 8x, right? If you have minus 8x and the top one is a positive 8x, they're going to end up canceling. Now, the trick is, well, what the heck do I have to multiply by? Well, if I want to make this an 8, I know I need to multiply by 2, but that gives me a negative 8. Now, a negative 8 and a negative 8 aren't going to cancel out, so I have to multiply by a negative 2. Negative 2 times a negative 4 will give me that positive 8. Okay, now again, let's distribute to every single term here, every single piece. I want to give the first equation a complete makeover. Negative 2 times negative 4 is positive 8x. Now, negative 2 times negative 7y is going to be positive 14y. Don't forget the last one. Negative 2 times 1 is going to equal negative 2. Now, the bottom one's going to stay the same. I don't have to give that one any makeover, anything like that. Bring it over. Is equal to 26. Now notice here when I go to add these two equations, well, I know 8x minus 8x cancels out. 14y plus 10y is going to give me 24y. Now when I combine these 26 and negative 2, well, that's going to give me 24. Hey, this is a one-step equation. If I divide both sides by 24, I know that y is equal to 1. Awesome, but I'm not done yet. Remember, you do have to get your x and your y value. So how do I get the x value? I know y is equal to 1. Well, all you have to do is plug it in. Now, it doesn't matter which one of the original ones, as long as you substitute in for the appropriate variable. Here it was y. I'm going to let's go with the first one. Why not? So I have negative 4x minus 7y is equal to 1. Now, again, I'm replacing the y here with what I know. In parentheses, that was equal to 1. Is equal to here 1. So I get negative 4x. Well, a negative 7 times a positive 1 is negative 7 is equal to 1. Hey, this is a two-step equation. Let me add 7 to both sides. I get these cancel out. I get negative 4x is equal to 8. We already start seeing this. If I divide both sides by negative 4, I get x is equal to negative 2. Now my solution, of course, is x equals negative 2, y is equal. Alright guys, so now it's your turn. Now I want you guys to skip example 1 for a second. You can try it if you want. I would use substitution for this. But I want you guys to try example 2. This is standard met. So go for it, pause the video here, and I'll explain the solution in a second. Okay, so here we have the solution. Now the trick behind this one was, hey, you got to multiply the bottom one by a negative 3 here. So that I can cancel out the x's. If you actually wanted to cancel out the y's, if this is a negative 2y, you could have multiplied this one by a positive 2, right? But again, both ways work. It's up to you. Flexibility here. Now, when you distribute everything to negative 3 to everything, you get negative 9x plus 6y is equal to negative 66. And of course, the 9's cancel out. 6y and 1y here give you 7y. Negative 66 plus 10 is negative 56. Divide both sides by 7. You get y is equal to negative 8. Same deal, take that guy and you plug it back in for the y here. Notice I put negative 8, negative 8. If you go through the multi-step equation, two-step equation actually, you get x is equal to 2. Alright guys, so here's your class activity now. Notice I got rid of number 5, okay, and one other thing. Okay, this is due tomorrow. I will be collecting this tomorrow when you guys come in. You'll turn it into the inbox, so make sure it's on a separate piece of paper. Again, this is building up your guys' responsibility, turning things in a timely manner. Alright, so you guys got 5 problems. Take a look at back at those examples. I'll see you guys tomorrow. Have a great day, you guys.